Here is nature and the propagation of light. This is the second class related to this optics, and we are in the second long question, which is here. You can see what is meant by a wavefront. Wavefront मानेको के हो? What is wavefront? And verify the Snell's law. That means refraction. Law of refraction on the basis of a wave theory. Wave theory को आधारमा Snell's law लाई प्रूभ गर भनेको छ. हामीले निकाल्नु पर्ने म्यू इक्वल टु सी बाई भी हो अथवा साइन आई अपन साइन आर म्यू स्नेल्स ल हो त्यो चाहिँ निकाल्नु पर्ने हो. सो द्याट फर्स्ट अफ अल लिसन आई ट्राई टु एक्सप्लेन अल इन इंग्लिश सो द्याट एन्ड समटाइम आई विल एक्सप्लेन इट टु नेपाली टु. फर्स्ट थिङ इज हियर क्वेसन. You can see here wavefront. Wavefront भनेको चाहिँ wavefront is defined as any instant at any instant is the locus of a particles of a medium vibrating in a same phase. Means look at here, this is the one of the here is particles they vibrating in a one phase. That means one phase they are vibrating in a one phase, so that they are vibrating in the same phase. And this locus, when we connect this point, then you can see one of the locus. That locus is called wavefront. And this wavefront means this way the light is spread out from the any lighting source, so that the light is coming from the sun. And here is you can see also every point on the wavefront. Here is, this is a wavefront, and every point you can see this point, this point, this point in the wavefront. They act as a source of a disturbance. They act as a source of a disturbance भनेको त्यो तलमाथि हल्लिने कामहरु गर्छ त्यो. अनि दिस डिस्टर्बेन्स फ्रम द पोइन्ट्स आर त्यो पोइन्टबाट भएको डिस्टर्बेन्स अब यहाँ पुग्यो भने यहाँबाट एउटा अर्को वेभ फ्रन्ट निस्किने भयो. अब यहाँ अगाडिबाट गरे नि यहाँबाट नि अर्को वेभ फ्रन्ट निस्किने भयो भनेपछि यिनीहरुलाई चाहिँ के भन्छ त वेभलेट्सहरु भन्छ. के भन्छ त वेभलेट्स. यु क्यान सी here and the front part here is wavelet also in this part, and again here is also another wavelet. You can see here this way. Here is means in this way the prime wavefront act, every point in a wavefront act as a source, and this moves ahead and back side, and where again there is formation of a one of the locus which we call के भन्छ wavelet भन्छ. अनि every point in a primary source of a primary wavefront मा भएको primary wavefront wavelet मा भएको प्रत्येक पोइन्टले आज पनि त्यो डिस्टर्बेन्स को काम गर्छ, अझ अगाडि जान्छ भनेपछि यहाँ पनि अर्को भन्ने भयो, यहाँ पनि अर्को, यहाँ in this way it moves forward, it moves backward. That means here is source. So in this way the light is spreading. That's why we can call the wavefront is one of the locus, and it is spread out, it gives disturbance, and due to this disturbance wavelet forms, and in this way wavelets moves forward and backward. The light is spread around our source. That is what you can see here in our first question. And the second one अब के भनेको छ भन्दाखेरि यो रिफ्लेक्सन अन द बेसिस अफ वेभ थ्योरी को अनुसार चाहिँ रिफ्लेक्सन चाहिँ कसरी प्रुभ हुन्छ स्नेल्स ल प्रुभ गर भनेको छ त्यहाँ स्नेल ल. Our another aim is to verify this Snell's law, so that first this you can see here figure one of the two of incident light. Suppose here incident ray LA and MP is going to incident on this denser medium. You know the outside is air, यहाँ चाहिँ हावा छ, यहाँ चाहिँ denser medium छ, and when these two waves strike or incident on the surface, then you can see it bends toward it, and here is also, and this wave is also bent toward it. And you can see here AP, what it is a plane wave front, and this is perpendicular to these two ray of incident rays, so that here is one, and this is angle of incident I, this is here you can see angle of refraction R, and this R would be here, and if you do the this if you look at here I you can see here too, and here is explanation. Let xy be the plane surface separating air from the denser medium. मानौ एउटा रिफ्लेक्टिङ मिडियम छ जसले के रे प्लेन छ जस जो चाहिँ xy हो जसले एयरलाई डेन्सर मिडियमबाट चाहिँ छुट्याएको छ. AP be the plane wave front हो जस्ट इन्सिडेन्ट on it भनेपछि AP चाहिँ यसमा ठोकिदै गइरहेछ. लेट AP र LP एन्ड MP, LP र MP दुईटा लाइटहरु इन्सिडेन्ट लाइट चाहिँ वेभ फ्रन्टमा चाहिँ इन्सिडेन्ट रेजहरु भनेपछि द वेभ फ्रन्ट अराइभ्स एट पोइन्ट ए फर्स्ट अफ अल वेभ फ्रन्ट ए मा पुग्छ त्यसपछि देन इट विल अराइभ्स एट बी एन्ड सी लेटर इन अ टाइम त्यसपछि हेर्नु त ए मा ए ड्यास भयो भने त्यसपछि बी बी ड्यास सी सी ड्यास भनेर यिनीहरू अराइभ्स भयो त्यहाँ पुगेर आउँछ भनेपछि therefore the different point in x y will become the source of a wavelet at any instant भन्नु के भने त्यो यो एक्स वाई प्लेनमा भएको यो पोइन्टले पनि सोर्सको काम गर्ने भयो यो पोइन्टले पनि सोर्सको काम गर्ने भयो यो पोइन्टले पनि सोर्सको काम गर्ने भयो अनि यसले डिस्टर्बेन्सलाई स्प्रेड आउट गर्ने भयो डिस्टर्बेन्स यहाँ पुग्ने भयो यहाँ पुग्ने भयो यहाँ पुग्ने भयो ए ड्यास बी बी ड्यास सी सी ड्यास means here is also one of the wavelet here is also one of the wavelet this means when they spread out disturbance you can see wavelet here अब त्यसपछि तपाईले यो I भनेको चाहिँ के हो त you can see LAN angle of incident I and N dash P dash M is an angle of refraction sorry you can see here N dash P dash M dash R you can see here another LAN is I when you can see when you compare here that would be also the I this one also would be R same as this one and let's मानौ यहाँ चाहिँ लास्टमा let's C with the velocity of light in air C चाहिँ light को velocity air मा छ V with the velocity of light in a medium here is medium light in a air and B with the velocity of light in the medium you know the C is light velocity in air and B with the velocity of light in a medium then the disturbance you can see here disturbance P dash in a air the distance of light which cover in a air is air मा कभर गर्ने डिस्टेन्स भनेको P dash हो भनेपछि डेन्स मिडियम मा कभर गर्ने डिस्टेन्स भनेको ए ड्यास यो हेर्नु त हावामा यसले हिनेको कभर गरेको डिस्टेन्स कति होला P dash भनेपछि ए ड्यास भनेको यो मिडियम भित्र चाहिँ कभर गरेको डिस्टेन्स दुईटैको बराबर हुन्छ हेर्नु त लुक एट फ्रम हियर when the disturbance shift from A to A dash here is also the disturbance shift from P to P dash you can see this shift in the disturbance this distance travel in air P dash and this disturbance travel that means the distance of a light in a medium is A dash I have seen here equal you can see that too here distance P dash in air equal to distance of light in A dash in a denser medium and when you divide this by this P dash divided by A dash you know the formula for distance के हो velocity into time यो air मा भएको हुनाले हामीले के गर्यो त P dash air मा छ नि त त्यही भएर C into T distance velocity into time भनेको त distance को formula हो नि त त्यसै गरेर you can see the A dash is the again velocity into time which is the formula of what distance and TT is same so we cancel each other C by V equal to I and this is equation and from these two triangle you can see triangle APP dash and triangle A dash P dash and from this triangle you could see there sin R equal to A dash AP dash you can compare from their figure to A dash P dash triangle A dash P dash triangle here is R when you apply sin theta sin R angle then when you apply sin trigonometric ratio then you can see here A dash divided by A dash AP dash and the same the way you again apply the sin angle in this APP dash triangle and then you can see here sin I equal to there is sin I equal to PP dash divided by A P dash and when you compare these two is this equation 1 and when we compare and when you compare sin I and sin I and with the sin R then you can write here Snell law mu equal to sin I upon sin R and in the place of sin I we write P dash divided by A P dash into in the place of a sin R you can see A P dash and A dash I have written from here in the place of a sin I and the sin R I replace all this value so that you can see here and when you cancel these two A P dash cancel each other then you can see here P dash divided by A dash this is equation 2 and from this equation and 1 and 2 when you combine you can see here P dash A dash equal to C by B. When you put in the place of P dash A dash equal to C by B, then you can see from this equation 1 and 2, sin A upon sin R equal to C by B, which is equal to mu, and which is the Snell's law. You know that is where you can see mu equal to refractive index of the medium. Hence this is what laws of refraction. You can see here refraction. Okay, reflection means that strikes on the medium and comes back to the same medium. Refraction means that goes inside this medium. So you can see here this Snell's law. Hence at last when you have this expression mu equal to C by B equal to sin I upon sin R, that is the law of refraction. Hence the law of refraction is proved on the basis of wave theory. That's all about this wave front and Snell's law on the basis of wave theory.